Hello everybody, welcome again to our course ETABS and SAFE and 11 meter span slab. Now we'll continue our work. And the previous lecture we prepared the structural plane and AutoCAD. We draw the contour line of the slab with specific layer, then the openings and the columns and the walls. Now, and we save the file AutoCAD as DXF. Now we are ready to go and begin with ETABS. We will use ETABS version 19. Okay, so we open the ETABS and we go to a new model. Let's go with metric here with use build. Okay, and we will go. Okay, or we can use save it user default setting. Okay, but let's define. Here the steel design. Now that we need the concrete, we need the ACI 19. Okay, so we press OK. Here we need a blank, okay, windows, number of story 1, the typical story height 3, bottom height 3. Okay, so we didn't need to define grids or use typical slab. Okay, here also we didn't need to define any grids in X and Y direction because we draw the system and AutoCAD. So we press OK. Okay, now we can go to file, import. Okay, we go to here. We need to import the DXF file that we prepared in the previous lecture. So we go to file, import, here DXF or DWG file of architectural plane. Now we go to the folder that we save the plan. Here, AutoCAD. This is the DXF plan that we save it in the previous lecture. We press open. The units is here, which was the unit is meter, okay, that we draw with it. Here we need to import this drawing and story number 1. We didn't have another story, so story number 1, and we press OK. We can show now this is our plan. Okay, the slab, the columns, the opening. We draw the opening on the stair also, and we have the walls. Okay, so we can go to display here now. To press here, we press here also on the architecture layers. We can go to the columns and right click on them and press add columns object. Okay, so now when we press this option or we use this option, we draw automatically the columns. ETABS automatically draw the columns. Also, let's try with the walls. Yes, also we get the walls with the same method. Okay, now we can go directly to the slab and press add area object. So now we have only to draw the opening. The opening we draw them manually, or we can use a very for example here, or we can go to here. Here we put it opening. Okay, now we can go to opening and press add area object. So when we put here opening the ETABS, so sorry for this error. So the ETABS, when we do here opening, the ETABS automatically put here directly opening with where we have draw the openings and AutoCAD. Okay, so now we have with quick method, okay, draw all the model. Okay, we can go to the 3D and show our model like this, and here, as we show here, we have this large space. Okay, so now if we look out of look to this plane, we will show that uh, this is a large span, so we need to work with it with special work differently with the usual standard mode and the normal project. Okay, first of all, if we look to this model, we know that we cannot use waffle slab or rib slab because the ribs will be very weak along this long span. Okay, also if we need to use solid slab, and as we know solid slab is not specific for this long, okay, this long span. So the must and the specific or the required system of slab necessary for this system is flat slab. Okay, and also if we go to the table of flat slab, this is for normal, okay, for normal project. Now in this project we will use the try and error, okay, method. So we assume that the thickness of this slab is 30 centimeter, okay, 30 centimeter. So we put it 30 centimeter and we put the loads and we do run, and we will check them after if we need to decrease or increase this thickness, okay, to prevent uh, the loss of time. Okay, so we can go, we define we want to define this thickness. You can go to section properties, slab. Okay, we can go, first of all we need to define, sorry, the material. So we can go to define material, we can go to here concrete, let's go with C25. okay, we need to use F'(C) 25. This is the unit volume, per unit volume, weight per unit volume, gamma of the concrete, always 25, and we go to here to put it 25. Here the Young modulus, okay, modulus of elasticity equal to radical of F'(C), sorry, times we have this number, so we put like this. Okay, this is it. So we press OK. Now we define the material. We can go to here, slab, we put as 30 and we put here 30. Okay, shell and sand slab, press OK. Now we select our slab and we go to assign shell slab S30 that we define. Okay, so now we assign the slab section that we define here into to our slab. Okay, press save. Okay, now let's go to the columns or the frame section. We can show F section 1, F section 2. This is ETABS defines them automatically from this section, or this section. If we go to here, we need to define material for the column. Okay, and go to material. So as we know, we define F'(C) for the column equal to, we put usually 30, F'(C) equals 30 megapascal, and here we will have 30 . we'll have this number. Okay, we press OK. Now we will go to section frame. For each material we will put C30. And also very important thing that we need to include automatic rigid zone over columns, because when we have columns, the part of slab near the columns is a rigid zone. Also here we need to check. Okay, include C30, include the rigid C30. Now to 5, the same step. Here, okay. Also, we need to define the material of the reinforcement rebar. If we go to this, so we have this steel section, we didn't need this. Here we have rebar. Okay, so we need to define the rebar. rebars. Okay, this is the gamma of the steel reinforcement, the modulus of elasticity. Here we have Fy. Here we have Fy times 1.25. Here Fye equal Fy times 1.1, and here equal Fu times 1.1. Okay, so we define the materials. Let's go and check the also if we repeat this. So here, okay, yes, automatically the ETABS define them. So now we define, also we need to check the walls. Also automatically ETABS define, we need to include automatic rigid zone. Okay, the thickness take it by the drawing on AutoCAD manually. Now here C30, sorry, okay, include the rigid zone C30, and also here we need to include rigid. Okay, so press OK. Now we can say that we have finished from defining all the section and modeling of our project. Also, if we go to the 3D, let's put X here, we need to go to the base and define the support of the base. Then go to assign joint, okay, pin support, normal pin support, and we go to the 3D. Now we assume that we need to this option to put support of the project, the plan, the base of the columns. Okay, so now we are ready to assign loads for this slab, and we can go to here. Okay, we have our slab like this. Okay, we also look here, we can also go to option architectural plan, deselect them, and we can go, so we disappear the architectural layers. Okay, so only here we have the structural layers. Okay, so now we need to look into this structural plane. We look that the mass damage will be appear, okay, surely here in this area. So we will show after if we need to draw a columns from this columns to this wall. Even if this beams go above the opening, it's not important, but we will show after if we need for this beam. Okay, so we assume the thickness is 30, And now we'll select the slab and we go to assign shell load uniform dead. Usually when we have flat slab and solid slab, we put 3.5 superimposed dead load, okay? And the ETABS automatically calculate the self weight, okay? Also, we have 2 kilonewton per meter square for the distribution, okay? So we put 2 plus 0, 3.5, okay? Apply for dead load. Now for live load, we have a residential apartment, so we put 2. And let's check, right click, loads, 5.5 and 2. Okay. So now we are ready to do. Also, we need to go to load combination, add default combination, slab design, first combination, okay, second, yes, okay, press save, and now we can go to do run. So we do run and ETABS. We can show, first of all, when we do run an ETABS for any project and the run terminate, we look directly to here. If we have normal numbers, not for example 1 billion or 1000, so this number minus 15 is a normal number. So this is a points that indicate that our work is, and the first step is right, okay? If we look here, we have used here minus 15. This is the mass damage point, okay? Here, also here, used minus 0, okay? We didn't have many damage here. Also here we have minus 4, so here is the maximum damage, okay? Now we will go to export this model because the design of slab is on SAFE, so we need to export this model to SAFE. So we can go export, okay, story as SAFE, story 1, select build and live here, okay, we save. Okay, so we terminate from modeling this the model and ETABS. Now we will go and to import this model and save. Thank you for your listening. We'll continue at the next lecture.